right, so last but not least, we need to write the name of the compound given the formula. So how to naming ionic compounds, excuse me. Let me switch to my pencil here. There we go. Naming ionic compounds is done very simply. It's done using the Stokes system. And in the Stokes system, what we do is it's really just two steps. Number one, we name the positive ion. So the first thing in the name is always the positive ion. And by the way, if you notice when we were writing these formulas, right, all the formulas I gave you, the positive ion is always given to you first. So that's always the case in the formula. So if you need to know which one's positive, it's going to be the first element in the formula. Pretty simple, right? So we name the positive ion, but remember there are two different ways to name. There's two subparts to this. One is where we have those groups 1 or 2, and the big 3, right? Those guys are named without Roman numerals. And then subpart B is where we have everything else. And for these, we're going to use Roman numerals. Fun, right? So one thing to remember on part A, we remove ion from the name. And we'll get to that in just a minute. Part 2, guess what part 2 is? If part 1 is naming the positive ion, name the negative ion. And so don't forget that ends in IDE, and that's why you're already familiar with this concept, right? Like all compounds pretty well end in IDE. Carbon dioxide, sodium chloride, right? And it's always because the negative ion is always given second. All right, so the trick here, right? Trick here is going to be that part B, and that's where things get a little bit complicated. So, for example, if I gave you the formula CaCl2, this one's pretty easy because here we have a group 2 element, all right? And the group 2 element, how do I know it's group 2? It's right there. Ca is in group 2, so not a problem there. So because that's a group 2, this one's really easy. Remember, group 2 would be calcium, and normally we call that the calcium ion. But remember, for this, we're going to remove the word ion. Now that I've named the positive one, we move to the next one, negative one. The negative one is chlorine, but remember your negative one always ends in IDE. So this is going to be calcium chloride. That's the name of this compound. We love seeing group 1, group 2, or any of the big 3, right? This could have been aluminum chloride or silver chloride or zinc chloride, right? Those are the big 3. It gets a little more complicated when we go to rule B, right? So if we're looking at 1B, things get a little more difficult because we might have something like, let's go with, I don't know, something from what we wrote down before, right? What if we looked for CON? CON, right? Now we've got an element that's not in group 1 or group 2. Cobalt is actually right here in the middle of the table. The negative ion is still going to be fairly easy. Doggone it. The negative ion is still going to be fairly easy. But we've got to worry about that positive ion. So what we need to do here is we need to reverse crisscross this compound. We need to go backwards. And so I always call reverse crisscross Sork-Sirk. Get it? It's crisscross backwards. Sork-Sirk. But some people just say crisscross backwards. That's fine. That's okay. That's cool. All right? But we're going to Sork-Sirk this thing. So remember what we've got to do to Sork-Sirk, all right, is we got to remember that these subscripts once were the charges on the opposite element. So I'm going to take my cobalt and my nitrogen, and I'm going to reverse Sork-Sirk it, or reverse Sork-Sirk is crisscross, right? Oops. Yeah, I'm going to Sork-Sirk this thing. So I'm going to take this one right here. I'm going to move it up there. I'm going to take this one right here. I'm going to move it up there. All right, that means my CO should be a +1, and my N should be a -1. Now right here, I'm going to stop, and I'm going to check myself before I wreck myself, which, by the way, is probably something Chris Cross said back in the 90s. They didn't invent that term, but I'm sure it's something that they would have said back in the 90s. -1 here. Do I expect nitrogen to have a -1 charge? So what I'm going to do is I'm going to check the negative. All right? And this is where things get a little tricky. We're going to go back up here. We're going to look for nitrogen. What charge do I expect nitrogen to have? Well, it's in group 15. There's a 15 right up there above it. So we're going to go back down here, and I'm going to say 15 minus 18 gives me -3. Uh-oh. That is not the charge I expect for nitrogen, right? I expect it to be -3, but it's actually a -1. So I got to remember, when somebody wrote this formula, they simplified this thing. And what they probably did was divided both these numbers by 3. So to get back to that -3, I need to multiply this times 3, because -1 times 3 gives me -3. And now I've got to start having PTSD, because I'm going to remember post-traumatic stress disorder, right? I'm going to remember my algebra days. If yours were happy, that's cool, but if not, right, you got to remember anything you do to one side, you've got to do to the other side. So we're going to take this, multiply that cobalt by 3, and we get +3 on that side. So what does that give me? I'm going to rewrite this one more time. So I'm going to boil this down into something simple. That cobalt is a CO, and I'm just going to go out to the +3 out there. And the nitrogen is a -3. So now I can name this thing. I already know, because I had to do all this work, that I've got to put a Roman numeral for that cobalt, right? Everything else on the periodic table, you got to put a Roman numeral. So we'll call this cobalt III, and I put mine in parentheses, nitride, because negative nitrogen is always going to be nitride. Pretty cool. And that's how you write the name given the formula.